So one type of question that you'll get is expand completely question. So an expand completely question like this one, 3b minus 1 to the 4, that's one where it is actually nice to use Pascal's triangle, so you can jot it off to the side. And if I have 3b minus 1 to the 4, how many terms are there going to be? There's going to be, when you expand it completely, 5. One more. So as far as Pascal's triangle goes, you have to go to row 5 where there's 5 terms. And those will be your coefficients. So when expanding this completely, 3b minus 1 to the 4 is going to equal, I know that I'm going to have 1, 4, 6, 4, 1 as my coefficients. What patterns did we notice with the variables? Right? We had A and B. A is our first one and B is our second one. Did you notice that you started with the first one to the power of 4? Plus, then you had the first one to the power of 3 and the second one to the power of 1. Then the first one squared and the second one squared. Then the first one just once and the second one cubed. And finally, the second one to the power of 4. The exponents always add up to 4. So here we have 4 exponents and none of the other, 3 and 1, 2 and 2, 1 and 3, and just 4. So the exponents always add up to whatever your initial exponent was. And now it says simplify, and this is where this question is different than the ones that we had before, because what happens when that 3b goes to the power 4? The 3 goes to the power 4 and the b goes to the power 4. 3 to the power 4 from your powers chart, 81. So our first term simplifies to 81b to the 4. Our second term, and sometimes you're going to want to simplify this in more than one step. Yes? 81 because 3b to the 4 is 3b times 3b times 3b times 3b. And 3 times 3 times 3 times 3 is 81. Can you see that here you're going to get 3 cubed? 27. 27 times 4? 108. Times a negative 1? Negative 108. And how many b's are we going to have in this one? 3. B cubed. 3 squared is 9. 9 times 6 is 54. Negative 1 squared is positive 1. So we will get plus 54b squared. Negative 1 cubed will be negative 1. Negative 1 times 3 times 4 will be negative 12. And negative 1 to the 4 is positive 1. So when we're expanding things completely, Pascal's triangle is nice, and using the pattern that we saw is nice. That our first term starts with the full exponent number and goes down by 1 each time, and our second term doesn't have any in the first one and goes up by 1 each time. And you know which row of Pascal's triangle to use because you know that there's always n plus 1 terms. So the fact that it's to the power of 4, you know that there's going to be 5 terms, and in Pascal's triangle, this is the row with 5 numbers. 1, 4, 6, 4, 1. So questions 3 and 4 are some expand completely ones.